So in this video, I'm going to discuss from question number 13 to question number 20. Right? Without further ado, let's start with the first question. Now he says, in a right triangle, the hypotenuse is 80. So let me make my right triangle first. Obviously, this is 90. Let me name this to be A, B, C. Hypotenuse is 8 through 3. Then he says, and the bisector of one of the acute angles. Obviously, one of these, right? So let me take this one. So bisector. So I will make the angle bisector. So AD is the angle bisector. This is equal to this. If this is theta, this is theta. So that I know. Now he says the bisector equals to 8. That means this length is equal to 8. Right? Write the length of the larger of the two sides. So whichever side is greater, AB or BC, whatever, I need to write the larger of the two. Alright. So that means, in short, I need to find these two sides. Right? Now, first thing that comes to my mind is angle bisector is there. So maybe I can use angle bisector theorem. Now, angle bisector theorem says this by this is equal to this by this. Right? Now, if I need to involve this by this, I do not know it, so I suppose it. Right? I suppose this to be x, this to be y, and then I can use this in terms of x and y. Right? Again, two variables are getting involved, quadratic equations. Okay, fine. What else can I use? Now the thing is, if I don't want to use angle bisector theorem, what else? It's a right triangle. Right? Pythagoras theorem, I do not know many sides, so maybe I cannot use Pythagoras theorem. What else? Right triangle is there. Maybe trigonometry can be applied. Because these two angles are equal, right? Maybe I can use that. Now, how should I apply trigonometry to this one? So, suppose I want to find it. So, let this be x, right? Because here parts were being there, so I was like, no parts, I'll just take AB to be x. Now, if this is x, this is a, that means I can write cos theta, right? So, cos theta from triangle ABD, that is x by 8, right? Now, obviously in order to find x, I need to set up an equation. That means I need to write another equation involving theta, because this is something that I introduced myself, and x, because I need to find the value of x. Now, theta will involve karna hai, x will involve karna hai. What else can I do? Now mind it, this was the right triangle. Here theta is getting involved, but this is not a right triangle. Okay. So, which triangle can I use which have 90 degree and which has theta? Theta so nahi hai, but I can have a right triangle with two theta is getting involved, right? So let me write it. Let's see what happens. So go to the big triangle ABC. Now cos 2 theta is x by a root 3. Cos 2 theta is equal to x by a root 3. This is theta. This is 2 theta. Interesting. Now even though I have both the equations in theta and x, but still here the angle has changed. Cos 2 theta. Do I know the relationship between cos 2 theta to cos theta? Even if I do not know that, I can easily derive it because I know the formula for cos of a theta. We have just done that in this class, right? So what I'll do is I'll put a as theta and b as theta. So this becomes cos theta into cos theta, so cos square theta, minus sin theta into sin theta, which is sin square theta. Right? So that means this is nothing but cos square theta minus sin square theta equal to x by 8 root 3. Interesting. Now, cos square theta, that means I can just put the value x by 8 whole square minus. If I can write sin theta, right, in terms of x, my problem will be solved. Minus sin theta. I'll go back to this triangle ABD. Sin would be this upon this. Now, this thing I can write using Pythagoras theorem in terms of x and y. So this is nothing but 8 square minus x square, obviously whole under root. So this is it. So sin theta is this by this. So square root of 64 minus x square whole divided by 8. Right? And this is equal to x by 8. Now as you can see, I have a quadratic equation in x. Right? So it is a very nice quadratic equation and it turns out to be root 3 x square minus 4x minus 32 root 3 equal to 0. Right? You can split the middle term easily. X turns out to be two values, 4 root 3 or minus 8 by root 3. Obviously, this will be rejected because side lines cannot be negative. Right? So, x turns out to be 4. Mind it, I need to write larger of the two. Anyways, it's an integer type, right? This is not an integer answer. So that means I need to find BC. BC I can easily find by using Pythagoras theorem. If this is 8 root 3, this is 4 root 3. Using Pythagoras theorem, I can find out that this is nothing but 12. Right? Obviously, out of these two, 12 is the greater one. That is why the answer for this question is 12. Alright, on to the next one. Now he says let alpha be the number of functions from this set to this set. Right? So if I want to visualize the function, maybe I can have the arrow diagram. I have just 2 elements, 3 elements here, 2, 3, 4. And then I have lots of elements here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, good. Now he says I need to find number of functions from this set to this set, okay, such that there is a condition. F of 2 and F of 4 are co-primes. F of 2 and F of 4 are co-primes. That means whatever the value they have, where HCF has to be 1. Okay, HCF has to be 1. Cool. And F of 2 and F of 3 are non-co-primes. F of 2 and F of 3, they have to be non-co-primes. That means HCF should not be equal to 1. That means some common prime factor should be there, right? Some common factor. Some common prime factor. Alright. These two conditions need to be satisfied, right? Then I need to find the value of alpha by m. Basically, I need to find number of functions which satisfy these two conditions. So let's start. Now, f of 2. So basically, I need to find out 2 can be associated with which of these elements, right? Let's start with. Let 2 be associated with 1, right? It's absolutely fine. Now he says f of 2 and f of 4, and these two have to be co-primes. So that means HCF has to be 1. Mind it, f of 4. If I take f of 4 to be 2, right? HCF of 1 and 2 is 1, right? So again, it would be co-prime. I can take f of 4 and to be 3, 4, 5, 6, so on. Any. It's absolutely fine. But at the same time, I need to make sure the second condition is also satisfied. Second condition is what? He says f of 2 and f of 3, they have to be non-co-primes. That means they should have a common prime factor. Mind it, f of 2 and f of 3. If I take f of 3 to be 1, right? 1, 1, HCF is 1, fine. I cannot take f of 3 to be 1. Do you think I can take f of 3 to be 2? HCF of 1, 2, that is 1 again. I mean, if the HCF is 1, that means they are co-prime. That means if you take f of 2 as 1, any other number you take with 3, definitely the HCF would be 1. Right? There would be no common prime factor. So that means you will get no function when f of 2 is equal to 1. No function. Rejected. Next case, f of 2, that is equal to 2. Let's start with this one. Let's see how it goes. Right? Okay. So f of 2 is 2. Mind it. Now, he says f of 4, HCF has to be 1. That means, if I need to talk about 4, either 4 can go with 1, right? Because 1 and 2, HCF is 1. F of 4 cannot be 2. Why? Because 2, 2, HCF of 2, 2, that is 2. So, f of 4 along with this, f of 4, either can be 1, it cannot be 2. Right? 3. 2 and 3, HCF is 1. So, yeah, I can take it. 4, no. Why? Because 2, 4, HCF is not 1. So, that means 4 is rejected. 5, yes. 2, 5, HCF is 1. So, 5 we can take. 2 and 6, HCF is definitely not equal to 1. So, I don't want 6. Then 7, yes. 8, no. 9, yes. 10, no. Right? Do I understand this? Right? Either f of 4 can be 1 or 3 or 5 or 7 or 9. Cool? Now, along with this, I need to talk about f of 3. F of 3. Okay, let's see. Right now, I want f of 3 and f of 2 to be non-co-prime. That means they should have a common prime factor. F of 3. Do you think I can put f of 3 as 1? It should have a common prime factor. So, answer nahi hoga. Do you think I can put 2? Answer is yes. Now, it has a common prime factor, that is 2 itself. Fine. F of 3 can be 2. Now, do you think I can put f of 3 as 3? HCF is 1 again, so no. What about 4? Yes. Because again, HCF is 2. 5, no. So this is rejected. 6, yes. 7, rejected. 8, yes. 9, rejected. 10, yes. Right? That means when f of 2 is, right, f of 3 can be 2 or 4 or 6 or 8 or 10. Now, let's see how many functions I have now. F of 2 is 6. F of 2 is 6. So, only one way to fill this? Right. F of 3, 1, 2, 3, 4, 5. 5 ways to fill it. Corresponding to this, I have 5 choices. So, in total, 5 choices. Right? Corresponding to each filling over here, I have how many choices? 5 again. Right? So, in total choices would be 25. Right? Simple. Now, this case is done. When f of 2 is equal to 2, I have how many functions? 25. Right? So, this was case number 1, rejected. Case number 2. Now, case number 3, I'll do it. Right? Now, f of 2 is done. So, f of 2, let me put this as 3. Right? Let me take f of 4. Now, mind it should be co-prime. So, that means I can take 1. I can take 2, yes. I cannot take 3 because if I take 3 and 3, HCF would be 3. So, 3, 9. 4, yes. 5, yes. 6. Problem. 3 and 6, HCF is definitely 3, not equal to 1. So, 6 rejected. Then, I can take 7, yes. 8, yes. 9, again rejected. HCF is not equal to 1. 10, right? Now, f of 4 I've selected. Now, let me talk about f of 3. Now, he says there should be a common prime factor. Mind it, this is 3. Common prime factor has to be 3 itself, right? So, it can be 3. It can be 6. It can be 9. Right? Number of functions. One way to fill this. How many ways to fill this? 3. So, corresponding 3i. Corresponding to this, how many ways to fill this? That is 6 and 6, 7. So, in total, 21 functions. Right? Now, next case, obviously, you will take f of 2 to be equal to 4 and you will write that. In that case, you will get f of 2 equal to 4, you will get 25. On similar way, you can exhaust it. Right? So, I will leave that up to you. F of 2 equal to 5 will turn out to be 16. Equal to 6 will turn out to be 21. So that you can check. Equal to 7, it will turn out to be 9. Equal to 8, it will turn out to be 25. Equal to 9, it will turn out to be 21. And equal to 10, it will turn out to be 24. Right? All the cases exhausted. 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And the number of functions. Add this. When I add all of these, in total, I am getting 187 functions. That means alpha is 187. But I don't want alpha. I want alpha by 11. So divide by 11. So obviously, the answer for this question turns out to be 70. Alright, moving on to the next one, which is a very interesting question. Now, he says call a positive integer n a 710 double if digits of base 7 representation of n form a base 10 number that is twice of n. First of all, I am unable to understand the statement, but fortunately for us, the example has been given. So, look at the example first. Now, he says 51 is a 710 double because its base representation is 102. Base 7 representation. So, that means 51 is given in decimals as in base 10 and 102 is given in base 7. And obviously 102 and 51, how are they related? I can write 102 as 2 into 51. Right? Now, this is base 7, just to be clear. And this is base 10, just to be clear. Right? Just clarify that. Now, how do I talk about the numbers where the base is 7? Right? In traditional sense or in the decimal system, we know the placeholders, right? 10 raised by 0, that is unit place. 10 raised by 1, that is 10 place. 100 place, 10 raised by 2. But this is base 7. That means here the place values is in terms of 7, powers of 7. Right? 7 raised by 0. Here the place value is 7 raised by 0. Here the place value is 7 raised by 1. Here the place value is 7 raised by 2. Right? That means 102, let it be as it is. 2 into. Now, how did I get this 51 from this one? Let me see. Now, this is the digit and the place value is 7 square, 7 raised by 2. So I will write it 1 into 7 square plus 0 into 7 raised by 1 plus 2 into 7 raised by 3. Right? This is 49 plus 2, which is 51. This is how have I written this thing in terms of this. But that is not my question. My question is, you need to find n, which is the largest 7, 10 double, and then write the value of n by 9. Basically, I need to find the largest 7, 10 double. Right? Okay. So let me consider my number to be in base 7. Right? Base 7. Because I started with this. My left hand side is this, so I'll start with this. My base 7 number, let that be, first digit is AK, second one is AK minus 1, then AK minus 2, and so on. My last digit, the second last is A1, last is A0. Right? This is my number. Now, if I need to utilize this thing, how will I proceed? Now, mind it, this is 102 as it is. 102 I have said. When I say 102, 102, that means I am saying 1 into 100 plus 0 into 10 plus 2 into 1. This is what I have said, right? If I need to read this, I will say it to be 102. That means if I need to read this number, I will say it like this, place value. Now, obviously here the place value is 10 raised by 0, 10 raised by 1, and so on, 10 raised by k minus 2, 10 raised by k minus 1, 10 raised by k. Right? I read this as 102, which is 1 into 10 square plus 0 into 10 raised by 1 plus 2 into 10 raised by 0. Same thing I will do it here. Right? So this is my number. Let me write it in this manner so that I can read it, which is AK into 10 raised by k plus AK minus 1 into 10 raised by k minus 1 plus so on plus A1 into 10 raised by 1 plus A0 into 10 raised by 0. Right? Left hand side I have written is equal to 2 into. Now the thing is, I need to write this thing. How should I write this thing? Mind it, my numbers remain the same. 1, 0, 2. But if I need to write this number, I have done 7 square, 7 raised by 1, 7 raised by 0. Right? So if I need to write that one, so ignore this one. I'm writing it beneath that. So 7 raised by 0, 7 raised by 1, so on. 7 raised by k minus 2, 7 raised by k minus 1, 7 raised by k. If I need to write this, I will write with the help of this one. Let me write it. So AK into 7 raised by k. So AK into 7 raised by k. Plus, next one, AK minus 1 into 7 raised by k minus 1. Right? Plus, so on. Plus, A1 into 7 raised by 1. I'll write that one. Plus A0 into 7 raised by 0. Done. Right? This is my so on. Right? This equation which I have written using the example, now I have taken my number to be like this and I have written this equation. From here to here. Right? If I need to find the number, basically I need to find AK, AK minus 1, AK minus 2, A1, A0. So many variables I can find it. Right? But first of all, what I'll do is I'll combine the like terms. Right? So AK is here, AK is there, combine the like terms. So shift everything to this side. I will get okay. AK into 10 raised by k minus 2 into 7 raised by k plus AK minus 1 into 10 raised by k minus 1 minus 2 into 7 raised by k minus 1 plus so on plus A1 into 10 raised by 1 minus 2 into 7 raised by 1 plus A0, that is 10 raised by 0 minus 2 into 7 raised by 0. That is equal to 15. Right? Mind it, let me just use the values that I can actually see it. Right? So let me rewrite this. So AK into, or maybe I'll rewrite it here only. So this is 1 minus 2, so that is minus 1. Right? Up. A1, the coefficient of A1 also I can easily write 10 minus 14, that is minus 4. In fact, I will write this one. So A1 into minus 4. And A2 also I can easily write it actually. So I will write A2 into. It will be 10 square minus 2 into 7 square. So 100 minus 98, which is 2. Right? Some I have written so that. Right. How should I proceed to solve the equation? There are too many variables. But mind it. Here k is a natural number. Right? AK minus 1, all of these A2, A1, A0, these are also natural numbers. I need to solve the equation over the collection of natural numbers. Okay. So, this is a natural number, okay. This is a natural number, okay. Natural number, natural number, natural number. Negative number is equal to 0. Mind it, you can see that if I take all of these numbers, these are all positive. Right? Because the coefficient will be positive. Obviously, I can see here 2, then something greater, then something greater. This is obviously far greater than 0, positive. Right? And obviously, the coefficients here A2, A3, so on, AK minus 1, AK. I'm considering them to be, yes, they can be 0, but they cannot be negative. Right? So that means all of these quantities are positive. These are only negative terms. And somehow positive plus negative becomes equal to 0. Mind it, this is barely, so I need to write this one. This is what? Minus A0. That is minus 4A1. Right? This is 2A2. Right? If I write A3 term, the coefficient of A3 actually turns out to be 340. And it keeps on increasing. Mind it. Right? This is the number in base 7. That means the numbers that I can use, that is 0, 1, 2, 3, so on to 6. Right? When I say the number is in base 7, that means I can only use 7 digits. 7 digits. That means maximum value of A0 can be 6. Right? Maximum value of A1 can be 6. So, if I take the maximum value, that's 6. This is minus 4 into minus 24. So, minus 6. I am like, no matter how big these numbers are, it will just be minus 30. That means the number that I get from here, it has to be 30. It cannot be greater than 30 because I need the right hand side to be equal to 0. Right? Now this number 314 into A3. Right? Obviously, if I put 1 over here, this will be far, far greater than 30. So that means I cannot put 1 over here. There's only one possibility. You have to put in 0. Right? So this has to be 0. Mind it, A4 even has a larger coefficient. That means it has to be 0. That means all of these before coefficients have to be 0. Huh? That means the only thing I need to worry about is this one. Right? My equation is not this. Because as I can see, these things will always 0. This 0, and previous to this, all are 0. The only equation that will turn out to be, that is this one. Right? So let me rectify this. So I will need a little bit of space. So what I can do is, I can erase my number. I can erase the question a little bit. Not the solutions, question. You already have the question, so it's absolutely fine. Still there. Right? So my equation is actually 2A2 minus 4A1 minus A0 equal to 0. Right? That's it. Now the thing is, my question is, if n is the largest 7, 10 double, right? N has to be the largest number. Now the number would be large if I have the beginning term, right? Which in this case it would be A2 because my number is not this much now. My number is baby number now because hardly 3 terms are there. So basically I have A2, A1, A0. 3 digits, right? Now if I want this number to be largest, that means I will make sure that this is largest. A2 is largest. Right. This is largest. That means I will want it to be 6, right? Because that's the largest digit that I can do. So A2 is 6, right? So that means it becomes 12 is equal to 4A1 plus A0, right? Now I want the largest number, so I would want the second number to be largest, right? That means A1 to be the largest. So obviously here the largest value of A1 that I can take, that is 3. Right, if that is the case, A0 automatically becomes 0. Right? So that means my number is 630. Mind it, that is not my n. I found the number, don't worry. I have the number 630. First digit, second digit, third digit. Right? Now, he says if n is the largest 7, 10 double. Now, mind it, I raised the question, but it was that if 51 is the largest 710 double, right? He said that 51 is the 710 double, this one. So that means right now we have the number in base 7. Right? But I call this number the 710 double, so that means I need to change this into decimal system. Right? How do I do that? Placeholder. 7 is for 0, 7 is for 1, 7 is for 1. Right? Actually, that will turn out to be, once you do the placeholder, the number will turn out to be 350. Right? 350. When I convert this number into decimal system, it turns out to be 350. That means this is my n. Now, n is established, I want n by 9. So obviously, I want 350 by 9. That is why the answer is number 35. Alright, moving on to the next question. Now he says two circles are tangent internally at P. The two circles, big circle and small circle. They are tangent at P. Alright, and the chord AB of the larger circle, so suppose my chord is something like this. Right? And we know that chord AB is tangent to the small circle. So obviously tangent at C. Right? He says PB and PA to join them. Done. PB and PA cut the smaller circle at E and D. So this is E and this is D. Cool. Now he says AB is 15. Cool. The entire length is 15. PE is 2. This tiny length is 2. And PD is 3. So this length is 3. Given to us. Right? We need to find AC. Mind it, AB is given to us, we need to find AC. Okay. Now, I need to find AC. Now, AC is the length of tangent from A. Right? Okay. I need to find out this one. Entire length is given to me, 15. I need to find this. Now, the thing is, maybe I can find BC. Right? But BC is also on the same footing as AC. Right? Because it is also the length of tangent from outside. Right? So, if I need to find AC, either first way is maybe I can try to find BC, or the second way is somehow if I can find out this ratio, AC-BC ratio, right, then I can find out AC. So, I'll go for the second approach. If the first approach was not working, I was not able to find BC, then maybe I can find this ratio, right? So, if I need to find the ratio, what can I do? Right. So, I need AC, so let AC be X. Obviously, this becomes 15 minus x. Right? Now, in this question, we have tangents and we have secants. Now, we have tangent, we have secant. Obviously, we can use PT square is equal to PA into PD. This theorem, I hope you remember this. Now, in this case, AC is the tangent, so AC square is equal to AD into A. AD into A. Right? Written down. Done. Now, obviously BC is the tangent, so I can say from here BC square is equal to BE into BP. BE into BP. Right? Now the thing is, I was interested in this ratio. AC ratio BC. AC ratio BC. Let me divide the two. Let's see what happens. Right? So AC square, I'll say x square, whole divided by 15 minus x whole square. Right? That is equal to AD by BE is equal to AP by BP into AP by BP. If I can find out these ratios, my problem will be solved. Now, out of these, one ratio is easily visible to us. This one. Till now, we have not utilized the fact that this is 2, this is 3. Also, we have not utilized the fact that these two circles are touching each other internally. How do I make use of the circles which are touching internally? Right? Whenever they are touching, that means there is a common tangent. Let me draw the common tangent. At this point, I will have my common tangent. Right? My common tangent. How can I use this common tangent? Mind it, this is a tangent to the bigger circle, right? And this is the chord of the bigger circle again. That means this angle would be equal to angle in the alternate segment. So two segments, this and this, alternate one, so that one. So if this is theta, this will be theta. Whatever results I know, let me just use them. Let's see what happens. Right? Also, same thing, this is attaining to the smaller circle. This is the chord of the smaller circle. So let me join these two. Right, chord of the smaller circle. Now, angle between tangent and chord should be equal to angle in the alternate segment. I can see one segment, two segments. So here, the alternate segment is this one. These two angles would be equal. If this is theta, this is theta. Right? Wait a second. This is theta, this is theta. What can you say about these two lines? They are definitely parallel. Observation. Okay. Whatever I know, I have written it. But since I'm interested in the ratios, right? Maybe BPT can be used, maybe similarity can be used, I don't know. Now, BPT will be used when there's a parallel line. I can say if these two lines are parallel. Now, if these two lines are parallel, that means this by this is equal to this by this. Let me write it. So, PD by AD is equal to PE by BE. Right? Is there a benefit to this? Let's see. If these two ratios are equal, can I say that this ratio will also be equal? PD by PE would be equal to AD by PE. I just cross multiply. Nothing more. Why am I interested in this one? AD by BE? Oh, AD by BE. That's right. Now, do you think I have the value of AD by BE? Let's see. PD by PE, pata mujhe? Yes. PD 3, PE 2. So that means this ratio is nothing but 3 by 2. Right? So at least I know this one ratio at least. 3 by 2 into. Somehow, if I can find out this one, my problem is solved. Right? My problem is solved. AP by BP. AP by BP. Interesting. AP by BP. Mind it, AP. How have I gotten AP? By adding this portion and this portion. PD and AD. If I add the two, I'll get AD. Wait a second. PD and AD, if I add the two, I'll get the bigger portion. Fine. Also, I want AP ke saath BP. So, BP. I need PE plus BE. PE plus BE. If I add these two and add these two, I'll get the required ratio. Now, I know the ratio property is PD by PE is equal to AD by BE. This ratio is actually equal to PD plus AD. Ratio property is that. Whole divided by PE plus BE. Right? And this is nothing but AP. And this is nothing but BP. Done? Now I know this ratio. We know PD by PE, that is 3 by 2. This is 3 by 2, 3 by 2, 3 by 2, 3 by 2. Done? AP by BP is also 3 by 2. AP by BB, 3 by 2. I think our problem is solved. Why? Because right hand side actually becomes 3 by 2 whole square. So, I don't even need to write this, that you can evaluate. So, AC square by BC square is actually 3 by 2. That means AC by BC turns out to be 3:2. 3:2. You know the entire length to be 15. You can use the quadratic, solve it, or you can see the answer. 3:2. That means this is 9. This is 6. I want the length AC. The correct answer in this case, that is 0. Alright, on to the next one. Now he says if n is the number of ordered pairs of positive integers a, b, such that the LCM of the two numbers is n, then write the value of n by 45. So basically I need to find the number of ordered pairs a, b such that the LCM is n. Right? So LCM is given to be 2q into 5 raised by 7 into 11 raised by 30. Right? I need to find the ordered pairs a, b. Mind it, LCM is given to us. Lowest common multiple. Right? Okay. Now we need to talk about a, b. The possible values of a and b. Mind it, a can have a factor of 2. Right? And maybe some power of it. Okay. Along with this, it can have a factor of 5. May or may not have. Right? 5 or 100 power and 11 100 powers. Right? Other than these three prime factors, there is no other possibility for another prime factor, right? Because it would have otherwise cropped up in LCM. So that means the only prime factors in A that can be there is 2, 5 and 11. Maybe all are there, maybe 1 is there, maybe 2 is there, right? Okay. Now B, obviously it might have a power of 2, it might have a power of 5, it might have a power of 11. Other than these three prime factors, there is no other possibility. So if I need to find out the number of ordered pairs, I need to find the different powers of 2, the different powers of 5, the different powers of 11. Right? Now he says that LCM is 2 raised power 3 into 5 raised power 7 into 11 raised power 13. Right? Now let's go back to junior classes. How do I get this 2 raised power 3 in the LCM? Mind it, I am talking about the lowest common multiple. Right? So suppose I have a number where the power of 2 is 2 and the other power is 2 raised power 3. So in the LCM, I would have 2 raised power 3. I'm not talking about the other prime factors which are there. I'm just talking about a single prime factor and its power. Right? Another case, let us take power 3. Suppose one power is 4, the other power is 7. In the LCM, I would have 3 raised power 7. Right? The higher of the powers goes. Now he says in LCM I have 2 cubed, 2 raised power 3. That means the higher powers have to be 3. Either it can be here or it can be here. Interesting. So let me talk about powers of 2 only. Powers of 2. Right? So A and B. Powers of 2. Right? So maybe A has the highest power, which is 3. Corresponding to this, there might be a case where B does not have 2. Any power of 2, right? It can be there. Because if I have 2 raised power 3 and 2 raised power 0, obviously in LCM I will take 2 raised power 3. Cool? Right. Now again, let the power of 2 be 3, but corresponding to this, let the power be 1. LCM would have 2 raised power 3. Another case. Then 3, 2. LCM would have 2 raised power 3. Then 3, 3. Right? In this case, the highest, obviously they are the same, the highest would be 3. Done? Now, you think I can have 3, 4. Mind it, if I do that, my LCM would have 2 raised power 4, but my LCM has 2 raised power 3. That means this power cannot exceed 3. Right? So maximum 3 can be there. Mind it, I am interested in the ordered pairs. Right? So that means I can have 3 over here and 0 over here. Right? I can have 3 over here, 1 over here, 3 over here, 2 over here, 3 over here, 3 over here. This I have already written. Don't write it again. Careful. Right? So these are the corresponding powers of 2 which are possible. Right? As you can see. Corresponding. I've written it. Yeah. 2 raised power 3, 2 raised power 2, 2 raised power 3, 2 raised power 3, then 2 raised power 0, 2 raised power 3, then 2 raised power 1, 2 raised power 3, 2 raised power 2, 2 raised power 3. Right? That means these are the corresponding powers of the 2. Now, either this will happen, this is one case only, or this will happen, or this will happen, or this will happen, or this, or this, or this. That means among these 7, there has to be one possibility. Right? So also I need to talk about powers of 2. Powers of 2. How many possibilities do I have? I have 7 possibilities. Right? Other than these, I cannot have any possibility. Interesting. Now, let's talk about power of 5 then. Right? So I will erase this now. Let me talk about power of 5. Now he says my LCM has 5 raised power 7. That means the highest of the powers is 7. Right? Maybe A has 7. Corresponding to this, maybe the power here is 0. So that means 5 raised power 7, 5 raised power 0. Another case, 7 and 1. As in 5 raised power 7, 5 raised power 1. Right? Next, 7, 2, 7, 3, 7, 4, 7, 5, 7, 6, 7, 7. Now obviously I cannot go 7, 8. I need to reverse it now. 7, 0, 7, 1, 7, 2, 7, 3, 7, 4, 7, 5 and 7, 6. Right? Either this case will happen or this or this or this. And how many cases these are? These are 15 in number. right? So that means powers of 5. They can be arranged in 15 ways. Last is powers of 11, that you will find out for your own good, right? That is powers of 11. Right? This will actually turn out to be 27. Right? Here I have talked about the powers individually. I need to make a number. Right? Now, powers of 2 can be arranged in 7. Now, I need to arrange powers of 5 also corresponding to this. Right? I need to arrange powers of 11 also corresponding to this. I think answer is there. Number of orders is 7 into 15 into 27. Right? That is equal to n. But I do not want n. I want divide by 45. Right? You can divide it, and that is why the answer for this question turns out to be 63. Alright, on to the next one. Now he says the real solution of this equation is alpha. You need to write the value of z of alpha, where obviously z of x denotes the greatest integer less than or equal to x. Right? So basically I need to find the real solution of this equation. Right? With 2 radical sign are being involved, that means I need to square it up. Now, obviously I will not do the squaring as it is. I'll shift one term to other side. So I'll write square root of 4x minus 1. That is equal to 3 plus square root of x minus 2. Mind it, before squaring, either I can proceed with domain, or if I'm not proceeding with domain, I will put and check the answer. Right? If I want to talk about domain, obviously this quantity needs to be defined. That will be defined when x is greater than or equal to 1 by 4. And this quantity needs to be defined, so and x should be greater than or equal to 2. So intersection of both of these, obviously I can write x is greater than or equal to 2. Right? Okay. Now, squaring it up, so I'll get 4x minus 1, that is equal to 9 plus x minus 2 plus 6 root x minus 2. Right? Then, if I shift everything to this side, and I will have the equation as 3x minus 8 is equal to 6 into square root of x minus 2. Right? And x is greater than or equal to 2. Right? Before squaring it up, what I'll do is, now right hand side is clearly positive. This has to be positive. That means 3x minus 8. Before I square it up, 3x minus 8 has to be positive. That means x is greater than or equal to 8 by 3. X greater than or equal to 2 and x greater than or equal to 8 by 3. I can see the intersection, that is this one. Cool. So this is the thing. Now you can square it up. In fact, I'll get the equation 9x square minus 84x plus 136 equal to 0. And x is greater than or equal to 8 by 3. Right? You can use quadratic formula. You will get two solutions for this one. You will get x equal to 14 plus minus 2 root 15 by 3. But along with this, I have x greater than or equal to 8 by 3. Right? Now, obviously, one I will reject. I'll reject the minus 1. You can put the approximate value of root 15 and get it. So, x in this case will turn out to be 14 plus 2 root 15 by 3. Right? Now, this is the solution. That means this is my alpha. Now, I need to find z of alpha. That you can easily find out. Put in the approximate value of 15, or you can just say it is just less than 4. So, you can figure that out. And in this case, actually, the answer will turn out to be 0, 7. Alright. Let's move on to the next one. Now, he says, write sum of exponents of prime factors involved in the largest positive integer m. Right? So whatever m is, it has to be the largest one. And I need to write the sum of exponents of prime factors. Right? That means if I prime factorize m, I need to write the sum of the exponents. Right? Now, condition. What is the condition? He says such that fourth part of the number of positive divisors of m. Right? Fourth part of number of positive divisors of m, right? कोई number होगा, natural number, उसकी fourth part, right? This entire thing should be equal to m. Okay, fine. I will reread the statement again. Now, he says you need to write sum of exponents of prime factor sign. Both हम बाद में देख लेंगे. Big deal. Now, we need to talk about largest positive integer m, such that fourth part of its number of devices, fourth part of its number of devices equals to the number. That means this number has to be a perfect fourth part itself. M has to be a fourth part. Right? Because fourth part of something equals M. So that means M is a fourth part. Now M is the fourth part. Let me prime factorize it. Right? So M is the fourth part. That means my part would be either it can be 4, it can be 8, it can be 12, it can be 0. That you understand. Right? So let me prime factorize this. So M looks like. Now prime factors. So first prime factor that has 2. Right? So it looks like 2 raised to 4 A1. A1 can be 0, it's absolutely fine. A1 can be 1, so my power will be 4, then 8, then 12, and so on. This is the first prime factor. The second prime factor, that can be 3, so I will write 4A3. Right? Into 5, 4A5. Into 7, 4A7. Into so on. Right? Clearly you need to find the value of M. Now, what is the condition? He says fourth part of the number of positive devices. First of all, I need to talk about number of positive devices of M. Right? Number of positive devices of M. If I need to write out, now first of all, suppose on the side, let's just discuss this thing. Suppose I have X and I have written X as 2 raised to P into 3 raised to Q. Whatever the values of P and Q. Right? Okay, I've written this natural number like this. I need to find the number of devices. Number of devices. Mind it, the devices can have the power of 2. The power can be 0. Yes. It can have 1. It can have 2. It can have 3. And the maximum power that can be P. Right? Okay. So that means the power of 2 can be accommodated in P plus 1. Corresponding to that, the divisor might have the power of 3. Again, 0, 1, 2, so on till Q. That means power of 3 can be accommodated in Q plus 1 way. Now, the divisors might have a power of 2 corresponding to the power of 3. So that means this into this. This is the number of devices. Right? If this is my number, the number of devices of this number turns out to be this. P plus 1 into Q plus 1. Can you see that? Right? Same thing, I'll use it here. Now, I need to write number of devices. Number of devices. Now, here P plus 1. So, here 4A1 plus 1 into 4A3 plus 1 into 4A5 plus 1 and so on. Right? If I multiply these, I get the number of devices. Now, he says fourth part of this. So, that means fourth part is equal to the number itself, L. Now, instead of M, I will write this one. So, 2 raised to 4A1 into 3 raised to 4A3 into 5 raised to 4A5 into so on. Right? Now, I will erase this part because I have explained. Let's see what happens. Now, first thing, power 4. Taking fourth root of both the sides, it's absolutely fine, I can do that. Gone. Right? So my equation looks something like this. Mind it, too many variables are involved, but we can still handle it. Let's see. Now first of all, if I need to find out M, let me have A1 first. Right? Let me try to find out A1 first. A1 is nothing but the power of 2. Okay? Power of 2 means even. Right hand side is definitely even. Okay? Left hand side. Let's see. 4A1 plus 1. Odd number. Okay. Odd number. Second 4A3 plus odd number again. Odd into odd. Odd. Okay. Odd into odd. Odd into odd. That means this is product of odd numbers, which will definitely be odd. Do you think you can have the value of A1 which will make odd number equal to even number? No. Right? That is not possible. If that is not possible, that means A1 has to be 0. At least I found one thing, that A1 is 0. So A1 is 0, so let me just get rid of this. Be gone. Right? Okay. I've made sure that this is odd. Now A1 is 0, so that means this becomes 1, so I'm erasing this also. And from here also A1 is gone, so this is done. So this is my M now. So let me move on to A3. Right? Out of so many, at least I found one. Now let me talk about A3. Now, what are the possible values of A3? Now, A3 can be 0, yes. Now, A3 can be something other than 0 also. When I say that A3 can be something other than 0, that means A3 is not equal to 0, right? This is what I'm saying. Okay, let's see what happens when A3 is not equal to 0. Right, A3 is not equal to 0. Now, corresponding to this, A5, I need to talk about A5, A7, A11, and so on. Now, how do I talk about all of these? Let me take the easier case first. When A3 is non-zero, let me take all other to be 0. Let's see what happens. Right? So, A5 is 0, A7 is 0, and all the coefficients except for A3, they are 0. Let's see what happens. If that is the case, now this equation, main equation becomes, let's see what it becomes. Right? So, A3, so this 4, A3 plus 1 as it is. Right? A5 is 0, so this becomes 1. If I write the next one, A4, A7 plus 1. If A7 is 0, this becomes 1. And so I will not write it, is equal to, now 3A3. If this is 0, this becomes 1. Now let me write another one also, 7 raised by A7. Right? This is 1, this is 1, so I will not write it. This is the case. Right? Corresponding to this, I can actually find out A3, can't I? If I put A3 as 2, I think the equation will be satisfied. Right? Obviously, you can put A3 as 0. Yeah, that is the case, but I am taking to be non-zero, we can do that. That means this is one such possibility. Let's see what happens. Now, I have taken A3 to be non-zero. Now, let me talk about A5. Now, A5 can be some number, right? If I say that A5 can be some number, that means A5 is not equal to 0. Now, we need to talk about the rest of them. Okay, talk about the rest of them. Now, it is difficult to talk about rest of them simultaneously. So, let me take the rest of them to be 0. So, A3 is 0, A7 is 0, A11 is 0, and so on. Let me see what happens. If that is the case, this equation becomes, now this is 1, so this becomes 4A5 plus 1 is equal to 5 raised by A5. Right? Now, for this, obviously, I can have A5 equal to 1. That means this is one possibility because I'm getting A5, something. Right? Okay. Now, let's see. Let's talk about A7 now. A7 not equal to 0. Rest all of them equal to 0. Let's see what happens. So, A3 equal to 0, A5 equal to 0, A11 equal to 0, and so on. This equation actually becomes 4A7 plus 1 is equal to 7 raised by A7. Mind it, when I put 1 over here, this is obviously 7, this is 5. When I put 2 over here, this dramatically increases and this increases linearly because this is a linear function. This is an exponential function. Right? Then I put 3, again 343 and this is barely 30. Do you think I can have a value of A7 which will make this is equal to this? No. Right hand side is increasing dramatically and left hand side gradually, slowly. Do you think left hand side would be equal to right hand side? The answer is no. Right? That means I cannot put A7 as something other than 0. This case is rejected. That means A7 has to be 0. See, I need to find the answer to the question. Whatever way I analyze, I'm just interested in the answer. And this is more than enough for me. This is logical enough for me because I can see if I put A7 as 4, obviously this thing will never be equal to this. Right? Okay. Let me talk about A11 also now. A11 not equal to 0 and rest all of them equal to 0. Do you think you will be able to find a solution? The answer is no. Why? Because my situation is something like 4 A11 plus 1 is equal to 11 raised by A11. This will increase dramatically and this will not. Right? So that means A11 also have to be 0. A11 is 0. What about A13? Again 0. That means all those things increasing ones, they have to be 0. So what are you even looking for? This thing. All of these are 0. Right? A7 A7 is 0, A11 is 0, A13 is 0, so that means this is into 1. Nobody cares about it. Right? So my number is just this much. Right? This I need to solve. Now this obviously I can find out since I want the largest positive integer. Now I will erase this part now. Right. Now he says my m is actually nothing but 3 raised to power 4a3 into 5 raised to power 4a5. Right? And my equation actually is 4a3 plus 1 into 4a5 plus 1. That is equal to 3a3, 3 raised by a3 into 5 raised by a5. I need to solve this one. So that I have the largest positive integer. You can start putting the value and you realize the largest thing that you can do is a3 is 2 and a5 is 1. If you go beyond this, the right hand side will increase dramatically and left hand side slowly. Right? So this is the only case possible. So we have a3, we have a5, just substitute it and you will get your m as 3 raised by 8 into 5 raised by 4. But that was not the question. This is my largest m. Right? He says sum of exponents of the prime factors. Sum of exponents. Exponent here is 4. Sum is 12. That is why the answer for this question is 12. Alright. On to the next one. Now he says a quadratic polynomial x square plus ax plus b is factored into linear factors. Right? So let me write this as x square plus ax plus b. That is equal to x minus 3 into x minus q. Right? Where obviously p and q are integers and a and b are also integers given to us. And a lies between 1 and 150 and b is a positive quantity. Right? You need to find the number of ordered pairs a comma b. Right? Okay. Ordered pairs a comma b. Now this is a polynomial, this is a polynomial. Right? So that means the coefficients would be equal. So x square, coefficient 1, 1, I don't care. Coefficient of x, a. Coefficient of x from here will be p plus q. Right? And second thing, constant term b, constant term from here is p. Right? Okay. Now mind it, I have the various values of a and b with me. A, especially a. Now first of all, let me analyze it. Now a is definitely a positive quantity. So that means p plus q is positive. Okay, right? P plus q. In fact, it should be negative of p plus q. Yeah, negative. So, okay. So let me rectify this. Now, this is a positive quantity. That means this p plus q has to be negative. Right? Okay. B is definitely a positive quantity given to us positive. That means PQ is positive. Sum of two numbers is negative, but product of two numbers is positive. Right? Now, product is positive, either both is positive and both is negative, but sum is negative, that means both have to be negative. This much I have reduced. Let me see whether this helps me out or not. Right? Okay. Let's see. Now, A is equal to minus P plus Q, so let me put A as 1. So, P plus Q will actually turn out to be minus 1. Now, you need to think of two negative numbers whose sum is minus 1. Can you think of that? The answer is no. That means A cannot be equal to 1. Okay, let's see what happens. Next case, let me take A equal to 2. Right? So that means P plus Q is equal to minus 2. Up. P plus Q minus 2. That means I can take minus 1, minus 1. Right? If that is the case, I have A as 2, then P is minus 1, Q is minus 1. That means B will turn out to be minus 1 into minus 1. 1 order flip. So that means because of this, I get 1 order flip. Yeah, success. 1 at least we got it. Next, let me put A as 3. Then A is 3, P plus Q is equal to minus 3. Possible cases. So I can have minus 1, minus 2. Then I have minus 2, minus 1. Right? Okay. Now, in this case, I need to have the possible ordered pairs A comma B. So A is 6, B. Now, in this case, minus 1 into minus 1, that is 2. In this case also it remains the same. Careful. So that means I will just get 1 ordered pair. Right? So that means I cannot interchange the values of this. Why? Because PQ remains the same. It's commutative. Right? From here I got 1 more. Let me put A as 4. That means P plus Q is equal to minus 4. So minus 1 minus 3, then minus 2 minus 2. Right? Minus 3 minus 1 I will not put because PQ remains the same. So I will not get another ordered pair. So from here, B I think can be put as 3 and then 4. That means 2 ordered pairs I got. Right? 4, 3, 4, 4. So 2 ordered pairs. So that means now I will just look at these numbers. I will not get B again and again because that will just waste my time. Right? Cool. Put A as 5 and I will get P plus Q is equal to minus 5. So minus 1 minus 4, then minus 2 minus 3. Then it will start repeating. I will get 2. Right? A is equal to 6. On the same line we can find it turns out to be 3. A is equal to 7 turns out to be 3. I think you can see the pattern very well. Right? Let's see. Leave 1, we don't care. 2, 3, 1, 1. So let me write the pattern. So 2, 3 is there, so I'll get 1 plus 1. Cool. 4, 5 is there, that is 2 plus 2. 6, 7 is there, that is 3 plus 3. 8, 9 is there, you can very well find out. It turns out to be 4 plus 4. Right? So that means I can go on till 148 to 149. Why? Because this is my pair that I will do. This would be now 2, 1, 4, 2, 6, 3, 8, 4, 148, 74, 74. Done. Last. 150 is lonely, it's okay. It's fine. 150 is lonely. Now, 2, 1, 4, 2, 6, 3, 150, 75. Right? From here, I got 2 ordered pairs. From here, I got 4 ordered pairs. From here, I got 6 ordered pairs, then 8 ordered pairs, and from here, I got 148 ordered pairs. And from here, 75. Right? As these are in AP, howsoever you want to calculate it, you can calculate it. The answer for this question turns out to be 45. Ultimately. Right. For the next solution from 21st to 24th, I will be discussing that in the next video.